Good afternoon, guys. Just let me know if you all can hear me, please. All right, cool. Now I know we have some people here, right? Just to make sure you all have it clear, this is Add Maths, right? This is not CSEC Maths. It is Add Maths we're talking about here, right? The multiple choice paper is tomorrow, right? So what I'm going to be looking at, I'm going to be going through the specimen paper for the 2021 Add Maths exam, right? I hope you all know that that the paper is going to be slightly different, right? There are going to be some additional questions on probability and statistics, right? All right, so let's start with the questions, right? Because we have about 45 questions here to do. So let me start, right? So the first question here, they've given us a cubic function, right? F of x is equal to x cubed plus 2x squared minus 5x plus k. And x minus 2 is a factor, right? Then they want us to figure out what the value of k is. Now, here's what this is telling me. If x minus 2 is a factor of f of x, that means that if I say, now this is what we're dividing it by. We're dividing it by x minus 2. So therefore, if we put x minus 2 equal to 0, we're going to get x is equal to 2, right? Now the fact that x minus 2 is a factor, that means that f of 2 has to be equal to 0. That's what that means, right? So what I'm going to do, I'm going to substitute 2 into this function f of x, and I'm going to put that equal to 0 and then solve for x, right? That's what I'm going to do. So let's see. So what we're going to do, we're going to write down what f of x is. So f of x is equal to x cubed plus 2x squared, right, minus 5x plus k, right? But we're going to find f of 2. So you're going to substitute 2 into this expression here. So this is going to be 2 cubed plus 2 multiplied by 2 squared minus 5 multiplied by 2 plus k, right? And we know that that is supposed to be equal to 0 because x minus 2 is a factor, right? X minus 2 is a factor. Now, what we're going to do here now, so 2 cubed is going to give me 8 plus 2 squared is 4, 4 2s are 8, minus 10 plus k is equal to 0, right? 8 and 8 is 16. 16 minus 10 is going to give me 6. So 6 plus k is equal to 0. Therefore, k is equal to minus 6, right? So k is equal to minus 6, right? So that gives us A as the answer for this question here, right? Question 2. We have, now this is maths. This part here is not even maths as far as I'm concerned, right? So here's what we have here. We have L multiplied by M plus N, right? Minus M multiplied by L plus N, right? So what we're going to do, we're going to use our distributive law in order to expand this, right? So what I'm going to do, I'm going to say this L multiplied by this M, and then I'm going to say this L by this N. Then I'm going to say minus M by L, and then minus M by N. So let's work that out. So this here is going to give me LM plus LN minus ML minus MN, right? Now, if you look carefully, you realize, wait a minute, this term here is going to cancel this because LM is the same as ML, right? So when you subtract that, that's going to disappear. So what you're going to end up with is LN minus MN. Now, none of the answers look like that as yet, right? So I can factorize this, and I'm going to end up with N open brackets L minus M, right? So it's N open brackets L minus M. So that gives me an answer of C, right? So my answer for this particular one here is C, right? So moving on, third question here. So they gave us a quadratic function, right? And they said by completing the square, f of x can be expressed as something, right? So this is what we have. We have f of x is equal to minus 5 minus 8x minus 2x squared, right? And we want to complete the square, so we want to write it in a format that makes sense to us, right? Completing the square. So here's what I'm going to do. I'm going to write over this equation as this. I'm going to put this as minus 2x squared minus 8x minus 5, right? All I've done, I've shifted around the terms, right? But I'm keeping the sign in front of each of those terms. Now, here's what we're going to do now. We're going to factorize, we're going to complete the square like we normally would, right? But the first thing I'm going to do, I'm going to factor out minus 2. So I'm going to pull out minus 2 here. And what I'm going to end up with, this is going to be x squared, right? This is going to be plus 4x, right? And then this here, I'm going to write this as plus 5 over 2, right? So what I've essentially done, I've factored out minus 2 in this expression, right? That's all I've done. I factored out minus 2. Now, the next thing I'm going to do now, I'm not going to do anything with the minus 2. I'll leave it right here, right? And what I'm going to do, I'm going to try to complete the square for this, right? So let's leave our big square brackets here. So if we complete any square, this is going to be x. What we need to do, we need to find half of this term here, right? So this is going to be x plus 2. And this will always be squared. You have to write back whatever this term was. So it's plus 5 over 2, right? Minus, right? What you're going to do, you're going to square this. So minus 4, right? So then we're going to close our brackets here. So then this is going to be minus 2, open brackets. So this is x plus 2 squared. And what I'm going to do, I'm going to say 5 over 2 minus 4. I'm going to use my calculator for that. 5 over 2 minus 4. And that's going to give me minus 3 over 2. So this here is going to be minus 3 over 2. Right? Now I need to multiply everything by minus 2 now. So this is going to become minus 2, open brackets, x plus 2 squared. Minus 2 by this is going to be plus 3. So this here is going to be plus 3. Now the answers are, as they've written it here, I can write this as 3 minus 2, open brackets, x plus 2 squared. Right? So that gives me, which answer is that? That is C. So my answer for question 3 here is C, right? So just to make sure you guys understand, right? I don't want to make sure, I don't want to have some students here sitting in the class and they think it's maths, right? This is Add Maths we're talking about here. This is not CSEC Maths. This is Add Maths, right? And this is for those writing exam tomorrow. Now, moving on to the next one here. Question 4. The nature of the roots of a given quadratic is described as real and distinct. So we have, if we want to know if the roots of a quadratic are real or distinct, right? What we need to do, we need to find something called my discriminant, right? And your discriminant is actually this. First of all, let me tell you something here. So a quadratic looks like this. Ax squared plus bx plus c. But if I know these coefficients here, if I know a and I know b and I know this constant here, from that information, I can tell the nature of the roots. So b squared minus 4ac, right? If it is less, let's do the greater than first, right? If it's greater than 0, then what we're gonna have real, right? And we're gonna have distinct roots, right? That's what that is. Now, graphically, what that means is that if I were to draw a graph, right, that graph will look like this. And this will be one root, and this will be a second root. So I have two roots, and those roots are real. If, however, I have something like this, b squared minus 4ac, if I work it out and I get it equal to 0, right, these are real roots, right, but they're also equal. Right? So they're the same. Now, what does that really mean? It means that if I were to draw a graph, this is what's going to happen. That graph is only going to meet my x-axis. So I have one solution, right? And then we have a third scenario where if we have this, b squared minus 4ac is less than 0, meaning that it is negative. If you have a situation like that, what happens is that you have no real roots, right? From a graphical perspective, this is what's going to happen. If you draw the graph, right, it's never going to meet your x-axis. So you have no solutions. So here's what they want. They want real and they want distinct. So therefore, b squared minus 4ac has to be greater than 0. So therefore, my answer has to be D here, right? My answer is D, right? So that's correct. I saw some of you all say that. That's fine. So that's question 4. Question 5, what they want here. Given that, so they give us a domain and they said the maximum value of 4 minus blah, 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 blah. The value of x for which, okay, so let's do this. Let's call this f of x. So let f of x equal to 4 minus x plus 1 squared. Now, how they've given us this equation here, they've actually written it in the completed square format, right? So these numbers mean something to us. You see this 4 means something. You see this here, this means something as well. So the question wants to know, they want to know our maximum value. Now the fact that we have a negative sign here tells me that this function has a maximum value, right? Now they want the value of x, which is occurs, and they want the maximum value. So all we need to do, we need to say x plus 1 equal to 0, and therefore x is equal to minus 1. So this here is where my maximum value of x. That's not, I'm just watching how they ask the question, right? Let me make sure. Right. So they want the maximum value first, and they want the value of x at which it occurs, right? So the value of x is this. So the second part of my answer should be minus 1. So it's either B or C. Now, the maximum value in this case here, so my max value, right, is simply whatever this constant is here. That's this 4 here. So therefore, my maximum value is 4. So the answer has to be C, right? Now, when you get these questions, guys, you need to read it properly, right? You need to read it properly. So that's the answer there. The answer is C, right, for question 5. Now, in this one here now, they've said that alpha and beta are the roots of an equation, right? So they give us a quadratic equation there, and they said that alpha and beta are the roots of the equation. So let's do some things first. So before I work the problem, let's do this. So we have 3x squared minus 4x plus 1 is equal to 0. Now, based on this equation here, this here is A, this here is B, and this here is C. So therefore, what we're saying is A is equal to 3, B is equal to minus 4, and C is equal to positive 1, right? Now, they've told us that the roots of the equation are alpha and beta, right? Now, here's what's happening here. So we know that the sum of my roots, right, the sum of your roots is actually equal to minus b over a. You all need to know that formula. And the product of the roots, that's alpha beta, is going to be C over A, right? So this here is going to be C over A. So these are things you need to know. When you add the roots, you get minus B over A, sorry, and when you multiply, it's C over A. Now, the question says here what? Figure out this value here based on the information they've given to us. Now, this is a very tricky question, right? So alpha over beta plus beta over alpha. So we're adding two fractions here. So therefore, first thing we need to do, we need to find our LCM. So the LCM is going to be, since you have beta and alpha, I'm going to just write it as alpha beta. You can write the beta first if you want, that's fine. Now, here's what you're going to do now. You're going to say, I'm going to take that alpha beta and I'm going to divide by this here. I'm going to divide by beta. So this beta will cancel here, and what you end up with is alpha. So this is alpha here. Now I'm going to take that alpha and then I'm going to multiply it by this alpha on top here. Now I'm working this problem like if I'm adding two fractions. So the same rules of adding a fraction, that's what applies. So alpha multiplied by alpha is going to give me alpha squared. Put back your plus sign from on top here. Then we're going to say, you're going to take the alpha beta at the bottom here. So this here, alpha beta, and you're going to divide that by this figure here, that's alpha, right? This will cancel with this and you'll end up with beta. Then I'm going to take that answer and then I'm going to multiply by this beta here. So beta by beta is going to give me beta squared. Now this question has a little trick in it that you have to realize. Now as it is right now, I can't solve it, right? But what I can do, you see that alpha squared plus beta squared? You all need to know that I can write that as alpha plus beta squared minus 2 alpha beta, right? So the top part, the alpha plus beta squared, I can write it as this equivalent that I have on top here, divided by alpha beta. Now the reason why I did that is because this top expression here, I can see the sums as an alpha plus beta, and I can also see the product, alpha beta. So at this stage now, all I really need to do is to substitute what I know for these fellas here, right? Now let's work out, so alpha plus beta, right? We said is minus b over a. So therefore that's going to be minus 4 divided by 3. So minus 4 divided by 3, that's going to give me 4 over 3. And then I'm going to find the product, which is alpha beta, which is c over a, which is 1 over 3. So it's 4 over 3 and it's 1 over 3, right? So now all I'm doing now, I'm substituting those numbers that I just worked out into this expression that I have here. So alpha plus beta squared, this is going to be 4 over 3 squared minus 2 multiplied by alpha beta, which is a third, right? Divided by the product alpha beta, which is divided by a third again. So let me pull out a calculator. I want to show you all exactly how I'm doing this in my calculator. All right, hold on. All right, let's put on this calculator here. Right, so you all see my calculator there, right? Let's work this out. So how am I doing this now? So it's 4 over 3 squared. So 4 over 3, I'm using the fraction part of my calculator. I'm squaring that, right? So I should get 16 over 9, right? It gave me an improper fraction here, that's fine. Minus 2 by 1 third, so it's 2 multiplied by 1 over 3, close the brackets, equal, and then I'm going to divide that answer by 1 over 3. And what I'm going to get is 3 and 1 third, right? Let's see what that is as an improper fraction. So that is 10 over 3, right? So that's 10 over 3. Let's see if they have any answer like that. So I'm seeing A as 10 over 3, right? So that seems to be the answer, 10 over 3. right? So the answer is 10 over 3, guys, right? Moving on, right? So you all can go back to the video after if you want, right? So this one here now, the range of values for which 2x squared, okay, so this is a quadratic inequality. So here's how you do this. So you have 2x squared is less than 5x plus 3, right? Carry everything to one side, so you end up with 2x squared minus 5x minus 3 is less than or equal to 0, right? So we need to factorize this. So 2x, and this could be x, right? And I'll put 1 here, I'll put 3 here, right? And let's see. So if I put a positive here and a negative here, that makes sense. 3 2's minus 6 plus 1. Yeah, this will work. So 2x plus 1, x minus 3. So here's what's happening here. So 2x, let's find our points of importance for us here. 2x plus 1 equal to 0, 2x equal minus 1, and therefore x is equal to minus 1. The next solution now is x minus 3 is equal to 0, and therefore x is equal to 3. So you have two values here. So what you should do now, you should draw a sketch, right? That's the easiest way to work this problem. So you need to put in minus 1, because I'm looking at these solutions here, and you need to put in 3 here. So what I'm going to do, I'm going to sketch my quadratic. Now the question is saying we need to look at the sign here. This says less than, right? So what that is asking me is what part of my quadratic graph is below my x-axis. That is what that means, right? So what is important to us here, so I'm going to just shade and just going to show you. So that's this part of the graph here we're talking about here. This part of the graph here, right? So basically any value of x between minus 1 and 3, if I plug it into my function, right, I'm going to get a negative value. So therefore, my answer, right, so your answer is actually this. X has to be greater than minus 1, and it has to be less than 3, right? Now, hold on, I just realized I made a little mistake here. Hold on. Hold up. This is minus a half. Right? So therefore this here is minus a half, right? My bad. So let's just fix this one time. So my answer should be minus a half x 3, right? Minus a half x 3. So therefore for question 7, the answer should be E, right? Right, so when you get a question like this in the exam, the easiest thing to do is to sketch a graph. Once you sketch a graph, it's easy to visualize what's happening here, right? We have a next one here, next inequality, right? All of these inequalities are on your syllabus, by the way, right? So, and I don't know if you all realize this. So if you all don't know this, you all are being tested on a new syllabus. The syllabus is slightly different. So functions is not on the syllabus. They've made some changes. Even the multiple choice exam that you all are going to get tomorrow is going to look slightly different. You're going to get some more questions on probability and statistics, right? So keep that in mind, right? That's why I'm doing the specimen paper. Right, so we have 2x minus 3 over x plus 1 is greater than 0, right? Now, if you have a question like this, there's a technique that we use to solve this. We need to multiply by, so you put back the 2x plus 1 over x plus 1. But what we're going to do, we're going to multiply that by x plus 1 squared, right? On the right hand side, if you multiply by the same thing, you're going to get 0. So I'm not going to write that there. So now, when I do this, right, this here is going to cancel with 1 of this. So what you're going to end up with is 2x plus 1 multiplied by x plus 1. Now again, this is a product of two linear. These are two linear variables here, right? So therefore, that's a quadratic, right? And again, if I were to solve this, I'm going to get 2x plus 1 is equal to 0. 2x is equal to minus 1, and therefore x is equal to minus a half. And the other one is going to be x plus 1 equals 0. X is equal to minus 1. What is wrong with me? I made a mistake again. Hold on. This is 2x minus 3. This is 2x minus 3, right? So let's do this over here. 2x minus 3 is equal to 0. 2x is equal to 3. And therefore x is equal to 3 over 2, right? So those are my two values, 3 over 2 and minus 1. So let's sketch this quadratic here. So I'm going to put in those two values we just worked out. So minus 1 and 3 over 2 is 1.5. So I'm going to put this here, right? So that quadratic is going to look like this. However, the question, we need to look at this inequality sign. It's a greater than sign. So what they have asking us here is which part of your graph is above your x-axis. So it's this piece here, right? So any value greater than 3 over 2. And it's also this piece here. So therefore, any value less than minus 1. So my answer, so this is what your answer is going to look like, right? And because those two values are not connected, right, we're going to have to write it as two different inequalities. So you're going to write x is greater than 3 over 2. So it's anything greater than 3 over 2, and it's anything less than minus 1. This here is my solution. So which one gives us that now? It looks like C. Right, so if you all see me make any mistake, just let me know. Right, if you're not sleepy here right now, so all right, so next one here now. So next we go on to indices now. So let me just write this a little bigger here. They want us to find the value of x, right? Now, some of these questions you need to be a little careful when you're working these. So this here is 2 multiplied by 4 to the power x plus 1 is equal to 16 to the power 2x, right? Now, if we look at the numbers here, the base numbers, right? I can write those numbers as 2 to the power something, right? And then we're going to apply the laws of indices here. So this here can be written as 2 to the power 1 multiplied by, you can write 4 as 2 squared, and all of that is being raised to the power x plus 1 is equal to 16. 16 can be written as what? 2 to the 4, 2 to the power 4 to the power 2x, right? So 2 2s are 4, 2s are 8. Yeah, that's correct. Now, we still need to do some simplifying here. So 2 to the power 1, we can't do anything with that. Now, when you are removing the brackets here for this one here, it's going to be 2 multiplied by x plus 1. So this is going to be 2x plus 2 is equal to 2 to the power. You have to take the 4 and multiply by 2x. So this is going to be 8x, right? So therefore, on the left-hand side now, since you're multiplying and you have the same base, you're going to have 2 to the power 2x plus 3 is equal to 2 to the power 8x, right? 2 to the power 8x. So therefore, so at this point here, since you have the same base, we can say therefore 2x plus 3 is equal to 8x, right? Now I could rearrange this here, and then I'll end up with 3 is equal to 8x minus 2x, right? So this here is going to be 3 is equal to 8 minus 2 is going to give me 6x. So therefore x is going to be 3 divided by 6, and therefore x is equal to a half, right? So that's question 9. Yep, so the answer is a half, right? So you take your time, right? And you work out the indices and you should be okay. right. So for those of you who haven't done so as yet, please hit like on the videos and please subscribe to my channel, right? Actually, next week, all my Form 4 classes are going to start, as well as I'm going to continue with my Form 5 classes, right? So my new Add Maths class is going to be starting next week, Monday at 5 o'clock, right? And that's paid classes, by the way. It's not free. So that is question 9. Let's go on to question 10. Again, another indices question. So here's what we have here. We have 3 to the power x squared is equal to 14 squared, right? 3 to the power. So what we're going to do here now, we're going to write this as 3 to the power x multiplied by 2 is going to give me 2x is equal to, oh wait, sorry. There's an easier way to do this, right? There's an easier way to do this. You have 3x being squared and you have 14 being squared. So what I can say here, I can say 3 to the power x is equal to 14, right? I can say that up front. And now to solve an equation like this, all we need to do, we need to take logs on both sides of the equation. Now I don't like when CSEC does this, where they just put log, right? Because they haven't indicated what base it is, right? So if this was Cambridge, log to base 10, this is how they write it. They put LG, and log to something called base E, right? Log to base E is written as LN. Now you all don't have to learn this in the exam, right? But log to base 10 is, we typically write it like this. But they haven't indicated what base it is. So what we're going to do, we're going to take logs on both sides of the equation, because all the answers, you just have log. So this is going to be 3 to the power x is equal to log of 14, right? If you have log 3 to the power x, I can write that as x log 3 is equal to log 14. So therefore x is going to be equal to log 14 over log 3. So this is my answer here. So which one gives us that? Log 14 divided by log 3, that is B, right? That's B. Right, so now we have a log question now. So we have log, so in this case they give us a base this time. So log to base 4 of 8 minus log 4 2 plus log to base 4 of 1 over 16, right? So we have an expression here that we want to simplify. So basically, what we're doing here, since everything is given to one base, I'm going to just do a slight readjustment, right? And it's going to shift around some numbers here. So I'm going to write log to base 4 of 8. I'm going to write this term, I'm going to bring it a little closer. So I'm going to put plus log to base 4 of 1 over 16 minus log to base 4 of 2. Now, there are some rules for logs that you all need to know, right? So if you haven't seen it before, if you have log to base b of a plus log to base b of capital B, I can write this as log to base b of a multiplied by b. That's one rule. Our next rule is this: log to base b of a minus log to base b of b is equal to log to base b of a divided by b, right? So these are some rules that you need to know for logs. So in the first instance here, I'm adding these two. So therefore I can write this as log to base 4. So since you're adding, you're going to say 8 multiplied by 1 over 16, right? Minus log to base 4 of 2, right? So this here is going to be log to base 4 of 8 by 16 by 1 over 16, sorry, is going to give me 1 over 2 minus log to base 4 of 2, right? So then, hope I write that is correct. So now we're subtracting these logs here. If you're subtracting logs, what we need to do, we need to divide. So this is going to be a half divided by 2, right? So a half divided by 2 is the same as saying, so this is log to base 4 of a half multiplied by 1 over 2, right? And this is going to give me log to base 4 of a half by a half is a quarter, right? And let me just show you something here one time. So log to base 4 of a quarter, right, can be written as log to base 4, right? A quarter could be written as 4 to the power minus 1. And there's a rule that says if you have something being raised to a power, I can write this as minus log to base 4 of 4. And log to base 4 of 4 is actually equal to 1. So this here is actually minus 1. The answer here is E. Right, so I know this looking like Greek to some of you all, right? But these are the kinds of questions that you could potentially get tomorrow, right? All right, so that's question 11, right? So I'm moving on. So question 12 here, we have some surds to work out. So what we have here, we have 1 plus square root of 3 divided by the square root of 3 minus 1. And they said they want us to simplify this. So what we do, right? Remember, we can rationalize a surd. And what we do, we multiply by the conjugate of this, right? So you're multiplying by root 3 plus 1 over root 3 plus 1, right? Root 3 plus 1 divided by root 3 plus 1 is just 1. So all you're doing here is trying to rationalize this surd, right? So here's how you're going to do that now. So if you have to multiply the top, it's going to be 1 plus root 3 multiplied by root 3 plus 1 all over. Now, when you multiply a surd by its conjugate, right, that can be written as this: root 3 squared minus 1 squared, right? So what we're using here to work this out is the difference of two squares. So this part here is maths, right? If we have the difference of two squares, they can be written as this. So what I'm applying here in this question here, I'm moving in this direction, right? So therefore, if I work out the top now, right, so you're multiplying a bracket, you all should know how to multiply the bracket. You're going to take this first term and multiply by this. So I'm going to get root 3. Then I'm going to take this 1 here and multiply by this. So I'm going to get plus 1. Then I'm going to take this root 3 and multiply by this root 3. So you're going to get 3. And then I'm going to take this root 3 and multiply by this 1. So I'm going to get another root 3. Divided by, now root 3 squared is going to give me 3. And 1 squared is going to give me 1. So therefore, let's see how we're adding up the top here now. So on the top, you're going to have, what is this? Root 3 plus root 3 is going to give me 2 root 3. And then 1 plus 3 is going to give me 4. And all of that is going to be divided by 3 minus 1, which is 2. And I can still simplify this. This 2 can go into this 1 time, and it can go into this 2 times. So therefore, this is going to be root 3 plus 2, which is D for number 12. Alright, so I said somebody said put it in the calculator and it'll simplify. Yeah, you could do that, because remember, you don't have to show any work in. This is multiple choice. You don't have to show any work in. Right, I see some people asking about the physics specimen. Well, I've already done the most recent papers with my class, so I won't be doing any physics today, actually. Right, I know you all have physics tomorrow, right? All right, so that is question 12. Let's move on to question 13 now. So question 13 now, we have summation here now. So this is what we have. We have sum, right? We're starting at 1 and we are going up to 20. And we have 3r minus 1. Now, you all are not expected to know any summation formulas, right, for CSEC Add Maths. So what we can do, we can write out what this series is going to look like. So when I substitute 1 into this expression here, 3 by 1 is going to give me 3. 3 minus 1 is going to give me 2. So my first term is 2 plus. Then I'm going to substitute 2 into this expression. So this is going to give me 3 to the 6 minus 1. That's going to give me 5 plus, and we keep going. So we're going to substitute 3 into it, right? Now this here, r equal 1 is my starting point. This is my ending point, right? In terms of what I'm going to substitute into this expression here. So if I substitute 3 into it, 3 3s are 9 minus 1, that's going to give me 8 plus dot dot dot. And the last term, when I substitute 20, 3 by 20 is going to give me 60. 60 minus 1 is going to give me 59, right? So that's what we have here. So therefore, if we look at the series properly, if you go from 2 to 5, you realize, wait a minute, I'm adding 3. If I go from 5 to 8, I'm still adding 3. So it seems like that's what I'm doing. I keep adding 3. So this here is an arithmetic progression, right? So this here, it's an AP. It's an arithmetic progression. My first term is going to be equal to 2, right? This is my first term here. My common difference is going to be equal to 3. And I also know what my last term is. My last term is 59. So the question wants us to work out this whole thing here, this whole summation. So therefore, that summation here, right? This now. Remember, there's a formula to find the sum of the first n terms of an arithmetic progression. So it's n over 2, right, into 2a plus n minus 1 multiplied by d. So you can use that formula if you want, right? But I'm going to use a different formula, which is this. Sum of my first n terms is equal to n over 2, right, into a plus l, my first term and last term. And the reason why I want to do that is because I know my first term and I know my last term. So this here, so we're talking about the sum of the first 20 terms, right? So this is 20 divided by 2 multiplied by a, which is 2, plus my last term, which is 59. So this here is going to be 59 plus 2 is going to give me 61. 20 over 2 is 10, so that is going to give me 610, right? So I'm getting B as my answer here, right? Right, so there's a formula sheet in the paper. I'm not sure how many formulas they have on it though. Right, they have some formulas. They have the formula for arithmetic series, geometric series. They have some. Actually, they have a good bit of formulas on the formula sheet. All right, so that's question 13. Right, so let's move a little faster here because there's like a lot of questions we have to look through. All right, so we have a GP. The first term of a GP is 16, so therefore A is equal to 16, and my fifth term, so your fifth term, right, is equal to 81. Now remember, the nth term for a geometric progression or geometric series is given by this, AR to the power n minus 1. So therefore, if it's my fifth term, A is 16, we know A is 16, multiplied by R, they didn't tell us what R is, n minus 1 is going to be 5 minus 1, which is 4, and that is equal to 81, right? They said, given that the common ratio is positive, find the value of the fourth term. So the question wants our fourth term. But before we can do that, we need to figure out what R is. So R to the power 4 is equal to 81 divided by 16. So therefore, R to the power 4, let's work that out. 81 over 16 right? You're going to get a fraction, right? It's AR, yeah. Right, so, hold on. Can't simplify that, so let me just find the fourth root of 81 over 16, right? So if I find the fourth root of 81 over 16, that should be 3 3s are 9, 3s are 27. So this will be 3 over 2, right? That should be what R is. R is 3 over 2, right? So you know what R is, you know what A is. So if you want to find the fourth term, so the fourth term is going to be equal to, so the formula is this, AR to the n minus 1. This formula is given to you in the exam, by the way. So this is 16 multiplied by my common ratio, which is 3 over 2, and that's going to be raised to the power 4 minus 1. So therefore, that's 16 by 3 over 2 cubed, right? So I'm using my calculator for that. So that's 3 over 2 to the power 3, so that's cube. Multiply by 16, and what I'm getting for my answer here is 54, right? So my answer is C. The answer is 54. All right, so moving on. So again, we have a GP again, right? So they gave us some terms in a GP. So it's 81, 27, right? 9, 3, so, right? And they want us to find the sum to infinity of this GP. So before we can do that, if we look at the GP, we know that A is equal to 81, but we need to figure out what R is. When you go from 81 to 27, 81 divided by, right. So what I'm doing here, to go from 81 to 27, I'm dividing by 3. If I'm going from 27 to 9, again, I'm divided by 3. And if I go from 9 to 3, I'm still divided by 3. So that tells me that my common ratio is actually 1/3. So my common ratio here is 1/3, right? I keep dividing by 3. Now, what do I want? I want the sum to infinity. So there is a formula for the sum to infinity. It is given by A over 1 minus R, right? So A in this case is 81 divided by 1 over 1 minus 1/3, right? So that's 81 divided by 2/3. So what is that? 81 divided by 2 over 3. And I'm getting 121.5. 121.5, right? So that answer here is C, right? So I know some of you all seen formulas that you've never seen before, but please, you need to know these formulas. The sum to infinity is A over 1 minus R. Next one here now. We have a coordinate geometry question. Let's see. So we have 2 points, and they want to know what is the perpendicular bisector of the line AB. So I'm going to label my 2 points first of all. So I have A, and let's call that 2 minus 3. Then I'm going to have B, and that point here is minus 10 minus 5, right? Now, before you guys do anything, please label your points. This helps so much, right? So I'm going to label this. I'm going to call this x1, y1. I'm going to call this x2, y2, right? So if I want to find the equation of a perpendicular bisector, first thing I need to do, I need to find my gradient. So gradient is given by this formula here. M is equal to y2 minus y1 over x2 minus x1, right? So my gradient, now because I've labeled everything here, is just a matter of substitution. So minus 5 minus minus 3 all over minus 10 minus 2. So that's going to give me minus 5 minus minus 3 is minus 5 plus 3. So this is going to give me minus 2 divided by minus 10 minus 2 is minus 12. So therefore this is 1 over 6, right? Now that's the gradient of AB, right? So this here is the gradient of AB, right, is 1 over 6. So the gradient of the perpendicular bisector So the gradient of perpendicular bisector has to be equal to -6. Because remember, when two lines are perpendicular, if I multiply the gradients, I'll get -1. Right? So the gradient of the perpendicular line is -1/6. But this is a perpendicular bisector. If it's a perpendicular bisector, it means that the perpendicular bisector passes through the midpoint of the line AB. So I need to find my midpoint, which is given by this formula now. x1 plus x2 over 2, comma, y1 plus y2 over 2. So this is a coordinate we're working out here. So all I'm going to do, I'm going to say 2 plus minus 10 divided by 2, comma, and then I'm going to say -3 plus minus 5 all over 2. So let's see, 2 minus 10 is going to give me -8 over 2. And -3 plus -5 is -8 again. So this is -8 over 2. So therefore, this midpoint here is going to be -4, -4, right? So I know my midpoint and I know my gradient, right? So the next thing I need to do now, I need to find the equation of the line. So you all may have seen this formula before. Y minus y1 is equal to m into x minus x1, right? That's the formula we're going to use in order to find my equation. So y minus y1. So just remember, you're using the midpoint here to work out this equation. So it's going to be y minus -4 is equal to my gradient, which is -6 into x minus -4. So therefore, this is going to be y plus 4 is equal to x minus -4 is x plus 4. So this is going to be -6x minus 6 4 is 24, right? Now I need to simplify this even further. Let's make sure, so I need some space here. I just want to make sure alright, so camera won't block you, so hold on. So in the corner here, I'm just going to simplify this, right? So let's see how the answer's looking though. So I'm going to write this as y plus 6x and then 4, you carry across the 24 to the left hand side. So this is going to be y plus 6x plus 28 is equal to 0. This here is what my equation of my perpendicular bisector is supposed to be. Which answer is that though? Y plus 6x plus 28, the answer is B. Yeah, the answer is B. Next one. So we have a line and they want to know where those two lines intersect and the coordinates are P. So what you have here, you have 2y minus 3x minus 13 is equal to 0, right? So we can call that equation 1. And the next one is y plus x plus 1 equals 0. So y plus x plus 1 is equal to 0. Let's rearrange this one time. Let's make y the subject. This is going to be minus x minus 1. And I'm going to call this equation 2. So what I'm going to do, I'm going to substitute this here into this equation. So this becomes 2 by y. So it's 2 multiplied by minus x minus 1 minus 3x minus 13 is equal to 0. So let's remove this brackets here. This is going to be minus 2x. 2 by minus 1 is going to give me minus 2 minus 3x minus 13 is equal to 0. So let's keep all our x's on one side. Minus 2x minus 3x is going to give me minus 5x. And this is going to be 13 plus 2. So minus 5x is equal to 15. Therefore, x is equal to 15 over minus 5. Therefore, x is equal to minus 3. So I figured out what x is. Then we need to figure out what y is. So y is equal to minus x minus 1. So I'm going to take this value here and substitute it for x. So this is going to be minus, and you substitute in minus 3 here, minus 1. So this is minus 3 is positive 3, minus 1. This is going to give me 2. So therefore, the coordinates of the point P is going to be minus 3, 2. So my answer is D. So that is question 17, right? Next one here. They gave us the equation of a circle, right? So the equation of the circle is given by x squared plus y squared plus 12x plus 4y minus 16 is equal to 0, right? And we want to find the radius of the circle, right? You want to find the radius of the circle. Now the general form of the equation of a circle looks like this: x squared plus y squared plus 2fx plus 2gy plus c, right? So I'm sure you should be familiar with this equation here. So if I equate coefficients, I can say that 2f is equal to 12. So therefore f is equal to 12 over 2. Therefore f is equal to 6, right? Again, if we equate coefficients, we can say that 2g is equal to 4, right? And therefore g is equal to 4 over 2. So g is equal to 2, right? And in this case here, my constant c is equal to minus 60. Now, the radius, if you know the general form of your equation of your circle, is given by this. It's given by f squared plus g squared minus c, and you have to find the square root, right? So therefore, f squared is going to be 6 squared plus g squared, which is 2 squared, minus 60 square root. So this is 6 6s are 36 plus 2 2s are 4 plus 60. So this is the square root of 100, and therefore this is 10, right? So the radius of my circle is 10, so my answer is B. Right, so moving on, because it's 45 questions we have to look at, right? Next question, we have a vector here, right? And they've given us, so the vector is this. The vector is P, that's what they're calling it. And it is 2i minus kj. And the length of the vector is square root of 13. So what that means is that this is equal to the square root of 13. Now, you all need to know how to find the length of a vector, right? So finding the length of a vector, all we need to do, so the length of this vector is given by 2 squared, right, plus minus k squared. And you have to find the square root of that. That's how you find the length of a vector. So this is going to give me 2 2s are 4, k squared, so it's 4 plus k squared, and we're finding the square root. However, they've told us that the length is square root 13. So therefore, 4 plus k squared, right, is actually equal to 13. So therefore, k squared is equal to 13 minus 4. So k squared is equal to 9, and therefore k is equal to square root of 9. Therefore, k is equal to plus or minus 3. But they told us that k is real, right? So plus or minus 3. The answer is A. Right, so that's question 19. Question 20 now, we have two vectors. We have vector A, which is 4i plus tj. And we have a vector B here, which is 2i minus 3j. Right? So there's a j here. Now they said the two vectors are parallel. If two vectors are parallel, what that means is that one vector is a multiple of the other. So if you notice something here, you have 4i here and you have 2i here, right? So if you compare the two vectors, if we multiply by 2, right? So if you multiply this by 2, let's use a different color here. If I multiply this by 2, 2i multiplied by 2 gives me 4i. So therefore, if I take this minus 3, I must do the same thing. I must multiply by 2. So if I multiply by 2, that means that t has to be equal to minus 3 multiplied by 2, which is going to give me minus 6. So my answer has to be A. Question 21 now. They give us two vectors. So they said position vectors position vectors A and B relative to an origin O. So here's what's happening here. So you have the point O, right? You have a vector OA and you have a vector OB, right? And the question wants the angle here, this acute angle here. Right, so there's a formula to work this out basically. So this is what we know. We know that the vector OA is actually equal to 2, 3. And the vector OB, right, is equal to 7, 4. Right? That's what we have here. So let's see. First thing we need to do, we should find the length of both vectors. So OA, right, is going to be simply equal to 2 squared plus 3 squared, and you find the square root. Right? 2 2s are 4, 3 2s are 9, and 4. That's the square root of 13. Right? Then we're going to find the length of OB. So this is going to be 7 squared plus 4 squared. Find the square root. So that's 7 times 49. 49 plus 16. That's 65. So therefore this here is equal to the square root of 65. Right? Now what else do we need? The formula is root. Alright, so we need to work out the dot product now. So we need to find OA dot OB, right? So this here is going to be the dot product, which will be 2, 3 dot 7, 4. So you all need to remember how to do a dot product. So that's going to be 2 by 7 plus 3 by 4, right? So that's 14 plus 12, that's going to give me 26, right? So there's a formula that we use to work out our angle, right? So where should I write this? Let me write it across here. So this is what the formula is. OA dot OB is equal to OA, that is length of OA, multiplied by the length of OB cosine of the angle theta that we want to find. So this is the formula that we're using to work this out. So what I've done, I've worked out the things required for the formula. So my dot product is, let's see if I can write this in the corner here. So 26, right, that's the dot product, is equal to the length, which is square root of 13 multiplied by the square root of 65 multiplied by cos theta. That's what you're trying to work out. So cos theta is equal to the 26 divided by the square root of 13 multiplied by the square root of 65. But the question wants the angle, the acute angle AOB, right? So that angle is going to be equal to cos of 26 over square root of 13 square root of 65, right? So which answer is that? That looks like D to me. Right? So question 21, I'm getting D for the answer. Alright, so moving on, need to pick up a little piece here. So we have some trigonometry here, right? And what we want to do, we want to add these two things here and basically get one of the answers that they have. So sine x, 1 plus sine x over cos x plus cos x all over 1 plus sine x, right? So what we're going to do here, since we have two different denominators, right? You have two different denominators. What we're going to do, it's going to be cos x multiplied by 1 plus sine x. Right. So now we add in like if we add in two fractions, right? So this, when we take this here and we divide it by this, you're going to end up with 1 plus sine x. And then I'm going to take that and multiply by 1 plus sine x here. So this here is going to be 1 plus sine x squared. Put back your plus sign. Then when we take this here and we divide it by this, you're going to get cos x. So cos by cos is going to give me cos squared x. Right? So let's see if we could simplify that top part there now. So the top part is going to be 1 plus 2 sine x plus sine squared x plus cos squared x all over. Can't do anything with the bottom, so leave it as is. So this is cos x by 1 plus sine x. So the top part now, you have sine squared x plus cos squared x. You should know that that's equal to 1. So you're going to end up with 2 sine x plus 2. Hope that's correct. So sine x plus 2. 1 second, let me make sure I'm doing this correct here. I worked it out before. Okay, yeah. So this is right. So everything is fine up to this point here. All over cos x by 1 plus sine x. Right? Now the thing is, the top part here, this top part here could factorize. So you can pull out 2. So this is going to be 2, open brackets, sine x plus 1 all over cos 1 plus sine x. Right? Now this here will cancel with this, and what you'll end up with is simply 2 over cos x. Right? There's an x missing here, sorry. So it's 2 over cos x. So the answer is B. Right? So you need to be careful with these types of questions. So they want us to simplify this here, right? So we have some rules that we have to use. So let's work this out. So you're working out cos into a minus b, right? I think they give you this formula in the formula sheet, by the way. Minus cos into a plus b, right? So that rule there is going to be cos a, when we expand this, is going to be cos a cos b, right? We had to change the sign. So it's going to be plus sine a sine b, right? Minus. Now, you need to put a big brackets here because you're subtracting this whole thing here. So this is going to be cos a cos b, right? This sign here has to change in the formula. So this is going to be a minus sign, sorry, not a plus. This here is going to be a minus, and this here is going to be sine a sine b, right? So let's see if we can simplify this. So this is going to be cos a cos b plus sine a sine b minus cos a cos b plus sine a sine b, right? This here will cancel with this, and what we'll end up with here is simply sine a sine b plus sine a sine b. So therefore what you're going to end up with here is 2 sine a sine b. So my answer should be A, right? My answer is A. Right, so that's 23, right? So moving on. Now they give us a question here. Sine theta is 15 over 7 and theta is obtuse, right? Determine cos theta. So what we need to do, we need to draw a little diagram here, right? With our quadrants. So they said the angle theta is obtuse. So therefore, The angle they're talking about here is this angle here, and that's theta. And what they're telling us here is sine theta is 15 over 17. Now remember that sine, that ratio sine, right, is opposite over hypotenuse, right? That's what we need to make use of here. So here's what we're going to do. So we're going to make use of this angle here. It's opposite over hypotenuse, so therefore this length here is 15, right? And my hypotenuse here is 17. So therefore we need to find what this adjacent is before we can do anything else. So that adjacent is simply going to be 17 squared, we're using Pythagoras theorem here, minus 15 squared, right? So using the calculator for that. So 17 squared minus 15 squared is going to give me 64. So this is 64. So we're finding the square root of 64. So this is 8. So therefore this length here is equal to 8, right? Now we want to work out cos theta. Now this is in my second quadrant, right? In your second quadrant here, right? That second quadrant there, cosine is negative. So therefore cos theta, right? Cosine is negative in my second quadrant, and cosine is adjacent over hypotenuse, right? That's what cosine is, adjacent over hypotenuse. So if we look at the diagram, the triangle, my adjacent here is going to be 8, but it's really minus 8 we have to put because I'm in my second quadrant. So it's minus 8 divided by my hypotenuse, which is 17. So it's minus 8 over 17. So question 24, the answer is B, right? So 24, the answer is B. Right, somebody's asking about it live. It should stay up, right? It should. It's set to record, so it should be there. All right, so here's what we're going to work out here now. So question 25, we have an equation. The equation is this: sine theta plus cos theta is equal to 0. Right? If you have to solve an expression like this, or an equation like this, sorry, what we do, we can divide everything by cos theta, right? You can divide by cos theta. So therefore, this could be written as sine theta over cos theta, right? Plus cos theta over cos theta is equal to 0, right? Sine over cos is going to give me tan. So therefore, tan theta plus cosine theta divided by cosine theta is 1 is equal to 0. So therefore tan theta is equal to minus 1. Now here's how we have to work this problem now. You must always draw these quadrants, and you need to remember all the ratios are positive in the first quadrant. Only sine is positive here, tan is positive here, and cosine is positive here. So what we need to do, we need to find or principal value, which is arctan of 1, right? I think that should be 45. So second function, tan, right? You're going to get 45. But if you look at the answers, you realize, wait, the answers are given in the form of pi, right? So therefore, my principal value is pi over 4. But the thing is, if you look at something here, tan is negative. Now tan is actually negative in this quadrant here and also in this quadrant here, right? Now they want the smallest positive value of my angle, right? So the angle that they're looking for, the smallest positive value will be this angle here. So to work out that angle, so therefore you work out theta as pi over 4, right? But that's not the final answer. Your actual answer, right? Theta is going to be equal to, I need to take, this here is pi, this is 0, this is pi on 2. So you need to take pi and subtract the pi on 4, right? This is what's going to give me my answer. So that is 1 minus pi on 4 is going to be 3/4 pi. So this here is 3 pi over 4. So I'm getting my answer as being B for question 25. Right? Some of these trigonometry questions, they're kind of trickier. Next one, question 26. Again, next. So we have 4 sine squared theta minus 1 is equal to 0. So if we work this out, we're going to get 4 sine squared theta is equal to 1. Sine squared theta is equal to a quarter. So therefore, sine theta is going to be the square root of a quarter. So therefore, sine theta, right, is going to be equal to plus or minus a half. So we need to work out theta. But they didn't ask us to work it out. They said for between 0 and 2 pi, right, the solutions of this equation lies in which quadrant? So the thing is, I have positive a half and I have negative a half, right? So if I were to look at my quadrants, right, A, S, T, and C, right? Now we're dealing with sign here. So let's look at this solution here. If we look at the positive value, then we should have an answer that lies in this quadrant and in this quadrant, right? If we look at the minus a half, sign is negative in the third quadrant and the fourth quadrant. So therefore, I will get 4 answers in all 4 quadrants. So the answer has to be D here for this one. Right? So this next one here. What do you want to work out here? Oh, you want to work out 2 sine open brackets x minus pi over 2. That's what we're trying to work out, right? Now, in order to do this, what we're going to do, we're going to use one of the expansion formulas here, right? So I'm going to expand this. You should expand this. So this here is, so let's leave the 2 on the outside. So this is going to be sine x, right? So it's going to be sine x cos pi over 2, right? Minus cos x sine pi over 2, right? So this is going to be 2 open brackets, right? Now pi over 2 is that's 90 degrees, right? So cos of 90 is going to be 0. So therefore, this part here is going to be 0. So this is 0 minus, and sine pi over 2, sine 90, it's going to give me 1. So therefore, this here is going to be just cos x, right? So therefore, I'm going to just end up with minus 2 cos x, right? Minus 2 cos x. So therefore, my answer is B, right? That's my answer. All right, next one here. We have our next expansion here. We have cos into A plus A, right? Now, when we expand this here, this is going to be cos A minus sine A, right? So you're going to end up with cos squared A minus sine squared A, right? Now, let's see. This cos squared A here, this, I can replace that with 1 minus sine squared A, right? Minus, so this is going to be 1 minus 2 sine squared A, right? So the answer is C. So let's keep moving. Oh, we have a next equation again. Okay, so we have 2 cos squared x plus 3 sine x is equal to 0. Alright, so what I'm going to do, I'm going to replace the cos squared here with 1 minus sine squared. So this is going to be 2 open brackets 1 minus sine squared x plus 3 sine x is equal to 0, right? Then we expand this, you're going to get 2 minus 2 sine squared x plus 3 sine x is equal to 0. Let's write this as minus 2 sine squared x plus 3 sine x plus 2 is equal to 0, right? Now as it stands there, we should factorize this. So this is going to be minus 2 sine x, open brackets, this will be sine x. We can put 1 here, we can put 2 here, equal to 0. And that is a minus sign here and a minus sign here. Yeah, so as that is factorized, right? So what we'll end up with is minus 2 sine x minus 1 equals 0. So minus 2 sine x is equal to 1. Therefore, sine x is equal to minus a half, right? So I'll work it out just now. Next one we have here is either sine x minus 2 is equal to 0. Sine x is equal to 2. This is not, you can't get that as a solution. So you have no solution for this. Right, so we're trying to work out sine x equal minus a half, right? So let's do our quadrant thing here again. So we're talking about sine, and sine is negative in my third quadrant and my fourth quadrant, right? So we need to find out the principal value first of all. So therefore x here is sine inverse of a half. You get 30 degrees. So that's pi over 6, right? So 30 degrees is pi over 6, right? This is not our answers yet. That is the principal value. So therefore, it's negative, right? So if it's negative, we need to find an angle here in our third quadrant and the fourth quadrant. So the angle in the third quadrant should be pi plus pi over 6. That's one solution. And the next solution will be 2 pi minus pi over 6, right? Now I can't go into too much details as to how we working out this. This is an in-class something here. So 1 plus 1 over 6 is going to give me 7 pi over 6. So this here is 7 pi over 6. And then 2 pi minus, so that's 2 minus 1 over 6. So that is 11 pi over 6. So this here is 11 pi over 6, right? So that looking to me like C. Question 29. Is that really C? Yeah. All right, so we have a next one here now, question 30, right? They gave us a sector and they want to know the area of the sector. So there's a formula for area. Area is a half r squared theta, where theta is in radians. So this is going to be a half multiplied by radius squared, which is 4 squared, multiplied by my angle, which is pi over 2, right? So this is 4 4 is 16, so therefore this is 8 multiplied by pi over 2, right? So this here is 4 pi. So your answer is B. So moving on now, question 31, right? So we're down to the fun stuff now, differentiation, right? So this is what we have. We have y is equal to 3x minus 2 cube. And you want to find dy dx, right? So you want to find dy dx. So there's a nice little formula we can use for this. If we have y is equal to ax plus b, to the power n, then dy dx is equal to n a multiplied by ax plus b to the power n minus 1, right? That's how we differentiate that. So therefore, this is going to be 9 multiplied by 3x minus 2 squared, right? That's my answer. 9 multiplied by 3x minus 2 squared. We just had to use a formula for that. That's it. This next one here now, right? We are using, this is a product, sorry, a quotient we're going to do here, right? So we have y is equal to 3x plus 5 all over 2x minus 11, right? And you want to find dy dx. So you all need to make sure you know your formula for my quotient. Let me just check. One second, I just want to check something here. If they give you that formula in the exam. Yeah, actually they, oh no, they don't. They don't give you that formula, so you need to know that formula, right? So what we're going to do, we're going to take the bottom part of the formula. So we're going to say 2x minus 11, sorry. And then we're going to multiply by the differential of the top, right? So when you differentiate the top, you're going to get 3 minus the top, which is 3x plus 5, multiplied by the differential of the bottom, which is 2, right? All over 2x minus 1 squared. 2x minus 11 squared, sorry. Right? Now be careful how you're simplifying the top. So let me just write this over a little neater. So this is 2x minus 11 minus 2 multiplied by 3x plus 5 all over 2x minus 11 squared. So I just realized in the question they don't want us to necessarily simplify it, right? So the answer looks like B. Hold on, let me just double check and make sure. Oh no, sorry, not B. We have a minus sign in between here. The answer is C, right? It's C. So just remember this formula. If you have U over V, so there's a formula you all need to know. Eh? So dy dx is equal to V d dx of U minus U dv dx all over V squared. So this is our quotient formula that you need to remember, right? Alright, so next one here now. We have a curve C, right? And they want to find dy dx at the point where x equal to pi over 3. So we have y is equal to 3 sine x plus 2. First thing we need to do, we need to find dy dx. So when you differentiate sine, you're going to get cos. So this is going to just be 3 cos x. When you differentiate 2, you get 0, right? So what you're going to do now, you're going to say when x is equal to pi over 3, dy dx is going to be 3 cos by pi over 3, right? So use a calculator for that. 180. So cos 60 is a half multiplied by 3. You're going to get 1.5, right? So what I'm getting here is 3 over 2 as my answer, which is B. Next one here now. We have a point P and they give us an equation and they want to know the equation of the normal. So be careful with questions like these in the exam. Sometimes they can ask you to find the equation of a tangent or a normal. You need to pay attention to that, right? So first things first, let's look at the equation that we have, which is y is equal to x multiplied by x minus 3 squared. Now you can differentiate this by using the product rule if you want, but you don't have to do that. What I'm going to do, I'm just going to expand this. So this is going to be x squared minus 6x plus 9. Remove the brackets, you're going to get x cubed minus 6x squared plus 9x, right? Next thing we want to find is dy dx. When you differentiate x cubed, you're going to get 3x squared, right? This is going to be minus 12x plus 9, right? Now, remember we're using the point P, which is 2, 2. So what we're going to say is when x is equal to 2, dy dx is equal to 3 multiplied by 2 squared minus 12 multiplied by 2 plus 9. Right? So this is 2 2s are 4 3s are 12 minus 24 plus 9. That's going to give me 12 minus 24. And that's going to give me minus 3. Right? But this here, this gradient that we worked out is the gradient of a tangent. So we need to say the gradient of a normal right has to be equal to 1/3. Right? That's what the gradient of normal is, 1/3. So we're going to use the point 2 2 to work this out. So the formula to work out the equation of a line is y minus y1 equal m into x minus x1. So it's going to be y minus 2 is equal to 1/3 multiplied by x minus 2. Anything looking like that? It looks like C for 34. Yep. Right, so that's my equation of my normal. This is not a tangent we're working out here. We're working out a normal, right? Question 35 now. They said an object moving in a straight line with a velocity given by this. What is the expression for the acceleration? So we have v is equal to 2 multiplied by t squared minus 6t plus 18, right? So therefore v is equal to 2t squared minus 12t plus 36. So you want acceleration. Acceleration is actually dv dt. That's what acceleration is. So dv dt is equal to, this is going to be 4t minus 12. No, sorry, did I make a mistake? 14 minus 12? Yeah, so that's 8. Question 36 now, we have an integral now, right? So this is what the integral is saying. So we're going from z, that's not 2, that's z. X squared dx is equal to 9. We need to figure out what is z. So what we're going to do, we're going to integrate this. This is going to be x cubed over 3. Put this in our square brackets here. And this here is going to be z. And this is going to be 0. And we know the answer is 9. So we're going to substitute the z and the 0. So this is going to be z cubed over 3. Right? Minus 0 cubed over 3 is equal to 9. So z cubed over 3, we can't do anything with that. 0 over... Right, so this is just going to be z cubed over 3 is equal to 9. Z cubed is equal to 9 3s of 27. And therefore z is equal to the cube root of 27. So therefore z is equal to 3. So my answer is A for question 36. All right, so next one here now, we have, they give us dy dx and we want to find the indefinite integral, right? So we have dy dx, right, is equal to 3 sine x minus 2 cos x, right? And you want to get the indefinite integral. So you want to integrate this. So y is going to be equal to, so you're integrating, when you integrate sine x, right, you're going to get minus cos x, right? So we integrate it. So this is going to be minus 3 cos x right? And when you integrate cos, you're going to get sine. So this is going to be minus 2 sine x plus a constant c. So which one is that? It's looking like C maybe. Yeah, so question 37, the answer is C, right? This next one here, we have the finite region R is bounded by the y-axis, the x-axis, and the arc of the curve, right? Shown in the figure above, and the area R. So they want us to work out this area here. That's what they want us to work out, right? So all we really need to do, we need to integrate. So that region R is simply going to be the integral. Now they give you the equation. It's y is equal to x minus 3 squared, right? And we're going to integrate, but we're integrating between this x value here, which is 3, and this x value here, which is 0. So my limits are 3 and 0, and this here is going to be x minus 3 squared dx. So this is what I'm working out basically, right? Now there's a rule to integrate this. You can expand it and integrate it if you want, or you can just use the rule, in which case it's going to be actually, you know what, let me just, not to confuse too many people. So if I expand this, it's going to be x squared plus 6x plus 9, right, dx. So let's integrate this in simple forms here. So this is going to be x cubed over 3, right, plus, when I integrate 6x, it is going to be 3x squared plus 9x, right? And the limits we're using here would be 3 and 0. So what I need to do, I need to substitute 3 and I need to substitute 0 into this equation. So when I do that, I'm going to get, so let's work this on the side here. This is going to be 3 cubed, right, divided by 3 plus 3 multiplied by 3 squared plus 9 multiplied by 3, right? You're working that out, and then you're going to subtract, you're going to substitute 0 cubed plus 3 by 0 squared plus 9 by 0, right? So everything on the right hand side is going to be equal to 0. So I'm going to use my calculator to work this out. That's 3 cubed is 27 divided by 3, that's 9, plus 27 again, plus next 27. And what I'm getting here, am I making a mistake? Well, that's not. I have a mistake somewhere here because I'm not getting the answer, right? Just, if you see the error, just let me know. Oh, sorry, I now see the mistake here. When I expanded it here, this should have been a minus sign, right? There's a minus sign here. Yeah. This here is supposed to be a minus sign, right? That's what the problem is. So let me work that out again. So that's 27 divided by 3. Alright, so what I'm getting for my answer, I'm getting 9 as my answer. So that's C. Alright, so that's question 38. Let's move on to 39 now. So they give us an equation for velocity and they want us to find the displacement at time t equal to 0. So they said the particle is moving from rest. That tells us something. When t is equal to 0, right, v is equal to 0 because you're starting from rest, right? And we will say that the displacement is 0 at that point as well. So if you want, so we have v is equal to 6t squared minus 4t plus 3, and I want to find displacement. So if you want to find displacement, we must integrate our, so displacement is equal to the integral of my velocity, right? So I need to integrate that velocity there. So therefore s is going to be equal to, right? So this is going to be 6t cubed over 3 minus 4t squared over 2 plus 3t plus a constant c, right? So that's the formula for my displacement. Now this could be simplified a little bit. So this is equal to 2t cubed minus 2t squared plus 3t plus c, right? But the thing is, when t is equal to 0, s is equal to 0. So therefore, what that tells me is that, so when t is equal to 0, s is equal to 0, so therefore, if I substitute 0 into this, I'm going to get my constant being equal to 0, right? So what that means is my equation is 2t cubed minus 2t squared plus 3t, right? So we're going to substitute t equal to 3 in this equation. So t is equal to 3. So therefore, s will be equal to 2 by 3 cubed minus 2 by 3 squared plus 3 multiplied by 2. So let's see what that is. 3 3s, that's 27 by minus 18 plus 6. So what I'm getting as my answer here is 42 as my displacement. 42. Alright, so I hope you all kind of following here. So like I said, if you haven't done so as yet, please hit like and subscribe to the maths channel. Right? What do we have here? So we have an integral here. So there's a formula to work out an integral that looks like this. Ax plus b to the power n dx is equal to ax plus b to the power n plus 1 over a by n plus 1. Right, plus a constant c. Right, so all I'm going to use, I'm just going to substitute into that formula there. So it's 2x plus 3 to the power 5 dx, and this is going to be 2x plus 3 to the power 6 over 6 by 2, which is 12 plus c. So therefore, the only answer that looks like that here is C. So that's question 40, right? Now remember, you're getting a different paper tomorrow, right? So there will be some statistics questions, right? Now they have the number of children in a family shown, so number of children and number of families. So therefore, this represents my variable, number of children. This here represents my frequency. So what we need to do, we need to work out our XF. Okay, the question wants, what does it mean? So we need to say 9 by 0 is 0, 10 by 1 is 10, 12 by 2 is 24, 7 3s are 21, and 4 2s are 8. So we need to add this up to give me my sigma XF, right? Which is 10 plus 24 plus 21 plus 8. That's going to give me 63. We also need to add up our frequency as well. So that's this. We need to find sigma f. So that is 9 plus 10 plus 12 plus 7 plus 2. And that gives me 40. Right? Now if you want to find the mean, x bar is equal to sigma xf over sigma f. Right? So this is 63 divided by 40. And what I'm going to get here is 1.575. So my answer is E. Alright, just now somebody's asking a question about, let's see what happened here. Let's see, what was the question? You have to multiply the derivative of the inside. Yeah, that answer is correct. The derivative of the inside here is 2. So I'm taking, so this here, what this really was is that 12 is really 2 multiplied by 6. The derivative of the inside is 2, right? And you would have had 6 at the bottom. That's the n plus 1. Now, question 42 here, right? They want to know what is, so they give us a box and whisker plot here, right? So you could get something like this in the exam, right? Something like this came in the paper 2. They want to know this distribution, what can be said about it? Symmetrical? No, it's not symmetrical, because if you look at this distance here and this distance here, it's not the same. So therefore it's not symmetrical. So therefore every answer that has 1 in it is wrong. So that eliminates this, this, and this one time. So automatically we know the answer is this, right? So use the process of elimination if you have to answer a question. Now this here is actually negatively skewed. And the reason why is because every single, like this distance here on the left is greater than on the right hand side. So the data is negatively skewed, right? Question 43 now, right? So the probability of an event occurring is 0.3, right? Probability of an event occurring is 0.3. So P of A is equal to 0.3. And the probability of an event B occurring is 0.6. So P, B is 0.6, right? Now, they are telling us, given that the two events are independent events, right? So they are independent events, and we're talking about conditional probability here, right? So A given B, so you all need to know this probability formula. It's A intersect B over the probability of B, right? That's what the formula is. Now, the thing is, these are what we call independent events. They said that. Right? Now, when you have independent events, right, probability of A intersect B is simply the probability of A multiplied by the probability of B, right? So therefore, what happens in this scenario here is probability of A multiplied by the probability of B all over the probability of B. This is going to cancel with this, and what you end up with is the probability of A, which is this figure here, which is 0.3. Right? So your answer for this here is going to be B. Right? Somebody said I made an error in question 39, which is question 39. All right, question 44, right? Two events are mutually exclusive, right? So when you have mutually exclusive events, right, what that means, if we use a Venn diagram, it means that the two events don't intersect at all. So this is C, this is D. The probability of C is 0.2. The probability of D is 0.3, right? And they told us that probability of C union D is equal to 0.5, right? And they want to figure out what is P, C intersect D, right? Now, here's the thing. If the two events are mutually exclusive, it means that the two events don't intersect at all. So therefore, C intersect D has to be equal to 0. The answer is A. So there's no work in there for us to do, right? There's no work in there to do, right? And the last question, right? So we have 50 students. We have 20 students study chemistry, physics. Okay, so some questions you may have to draw a Venn diagram. That's going to help you work out the problem. So we have chemistry, right? And we have physics, right? There are 50 students in the class. So the number in my universal set is equal to 50. You have 20 students study chemistry. So therefore, NC here on the outside is 20. And the number of students who study physics is 25. So NP is equal to 25. 10 study both. So 10 here is in the middle, right? And so what we can do, we can work out this here. This part here is going to be 20 minus 10, which is 10, right? So let me use a different color inside here. So this here is 10. And then we could work out this part here. This part is going to be 25 minus 10, right? Which is 15. So this here on the inside is going to be 15, right? So now we can work out what's going on what's happening on the outside, because they said who study neither of those subjects. So let's add up what we have inside the circles. So that's this 10 plus this 10, that's 20, plus our next 10, that's 35. So therefore, to work out this piece here, that's going to be 50 minus, let's add up, this 10 plus the next 10 plus the 15. So this here is going to be 50 minus 35, right? And this here is going to give me what? 15. So that is 15. So they want the probability. So the probability of neither is simply going to be 15 over the total number of students that we have, which is 50. So it's 15 over 50. So therefore, the answer has to be E, right? So the answer has to be E. Right, so let me go back here, the second to last line. Bryden is saying I have an error in question 39. Where is 39? So the second to last line. 2 by 3 cube. Oh yeah, right, yeah. So this is 3 here. Alright, thanks Bryden for spotting that error there. Alright, so guys, I've just completed the specimen paper. I know some of you all might be working past papers like crazy, right? But the format of your exam is going to be similar to this, hopefully, right? So I hope this session was productive for you guys, and I hope that you all are successful tomorrow, right? So good luck everybody, and you let me know the exam was, right? So guys, take it easy, and like I said, all my new classes are starting next week, right? So that's the Form 4 Physics, Chemistry, Maths and Add Maths. They starting next week. The Form 5 classes continue like normal, right? So anybody who's interested, this is my number here. You can always send me a WhatsApp, right? So guys,